If the potassium hydroxide is dissolved in alcohol and the haloalkane is heated under reflux, then the hydroxide ion present in the potassium hydroxide no longer behaves as a nucleophile but behaves as a base. So overall the reaction is that the hydroxide ion will remove one of these weakly held protons to form a molecule of water. And because a small molecule has been lost, then we call it an elimination reaction. Let's look at the mechanism. Here's the haloalkane, and because of the presence of the slightly electronegative bromine atom, what happens is the adjacent hydrogens or protons, the electron density is pulled towards or attracted towards this electron deficient carbon, and this renders these adjacent hydrogens, that is the hydrogens on adjacent carbon atoms to the carbon containing the bromine, are less tightly held than before. So hydroxide ions, as I mentioned before, can behave as nucleophiles but change the medium and dissolve it in alcohol or ethanol. Then it's a much less polar medium and the chance of a nucleophilic attack is reduced. So the hydroxide ions this time will still donate their pairs of electrons, but this time to a proton. So they behave as a Bronsted Lowry base, i.e. a proton acceptor. They could take either one of these two protons, and we represent this with a curly arrow going from the lone pair to one of those protons. Because the hydrogen can only have one covalent bond, and we're forming a covalent bond here, the bond between the carbon and hydrogen will break, and we can show the movement of electrons moving directly to this bond between the two carbon atoms. At the same time, the bromine atom will leave, so we show this with a double bond, with a bond breaking between the carbon and the bromine as the electron pair moves onto the bromine. Now the beauty of this pattern is the curly arrows all flow beautifully in the same direction. The movement of a pair of electrons onto the proton, this pair of electrons in this bond here moves to this bond, forming a double bond, and this bromine leaves. And therefore, if we remove this proton, we end up with a molecule of H2O. The bromine leaves and forms a bromide ion. Potassium ions are spectator ions in solution, and we end up with an alkene.